Hey guys, let's discuss new problem from graph and which is called find the cycle in a undirected graph using BFS. Okay, so you have given one graph and its adjacency list. Okay, now you need to find whether there is a cycle exist or not. So you know that in BFS we create a queue, okay, and then we create a visited array. So these two things, so definitely it comes right 0, 2, 3, 4 and 5. So now you visit each node and you mark it to true if it is traversed. Okay, now here what you will do, just a small difference. See, the concept is when you're adding node into the queue, that time you're adding it's a parent also. Okay, so that you will come to know that what is the parent of this node, from where it is coming. So for example, you have added all the nodes, okay, and you traversed from here. Now if you see in this graph, okay, let's take example of 2. Okay, you traverse from 0 to 3, okay, and then from 3 to 5 and 3 to 2, then from 5 you will go to 4. Okay, now when you have traversed 3 to 2, you have marked 2 to true. Okay, now you are coming from 4 to 2 also. Okay, but you are seeing that it is already traversed. So if 4 has not traversed this node, then who has traversed it? It means there is a cycle, correct? Because there is some another node also who has traversed this node, so it means there is a cycle in a graph. So that is the concept we will use. And if you see here, the structure of the node, okay, pair class. So in pair we have two integers, node and parent. Okay, that's it. So when you are adding the element from in a queue, you will add a pair. Okay, so let's start from 0. So let's try run it. So for 0, the parent node will be -1. Let's consider it. Okay, and you will pop element from a queue, okay, until it's not empty. Okay, so the size is 1 right now. So you will pop 0, 1. You will mark 0 as true. Now you visit all the neighbor node of 0 and put it into the queue. So neighbor is 3. Okay, so 3, what is the parent of 3? From where 3 is coming? From 0. So this one is 0. Okay, nothing else. So now you will pop this 3 also, 3 comma 0. So you will mark 3 to true. Okay, and then traverse its neighbor. So 1 is 2 and second one is 5. Okay, and who is the parent of this 2 and 5? 3. You're coming from 3, right? Now now pop this poll this 2 comma 3 also. So mark 2 to true and then 2 comma 3. So traverse all its node. Okay, so 2 you're going to 4 and 3. So 3 is parent, so just leave it because it is already traversed. And see, if any edge is coming from A to B undirected, okay, undirected edge is coming from A to B, so you can skip A. You will not consider A in a cycle because you're coming from A, so how can there will be a cycle, right, from A to B? So that's why if you see here, okay, so 2 is from 2 two edges are going 3 and 4, but 3 is already visited, but it is a parent, that's why we are not considering it. Okay, so you'll add 4 comma 2 into the queue. Now it's time for 5 comma 3. So you will put 5 as true, okay, in a visited array, and from 5 you are visiting 5 comma 3, yeah, from 5 you are visiting 4 and 3. Okay, so 5 comma 3 is the parent node. So 3 is already true, that is fine, it is a parent node, and so 3 we will not consider. 5 comma 4 you will add. Okay, so 4 and the parent node is 5, so you will add that 4 comma 5 here. Now next 4 comma 2 will come, so you will mark 4 to true, okay, and 4 comma 2. So from 4 2 edges are going 2 and 5, so we can skip 2 because it is a parent, and then we will see 5, but we are seeing 5 is already true, means somebody has traversed it already, right? It means there is a cycle exist. That's it. Okay, so let's see what is happening in the code. So see, your each cycle method will run. Okay, it will take your number of vertices and your adjacency list, this one, okay, which is a integer array, list of integer, okay, because this is one list and which is holding integer values, okay, and this is parent list which is holding multiple list. Now you will create one visited array, you will run one for loop, okay, I equal to 0 to v to for non-connected components. Okay, we have discussed very few times, like lots of time, that what is components in a graph. So for example, currently your graph is connected here, but you can have a graph something like this also. This is also one graph where you have two components, okay, which are not connected. So in that case, this for loop will be used to traverse the non-connected components. Now if it is not visited, then you run BFS, okay, BFS for that I, and then if everything is okay, then return true, otherwise return false. Okay, now what is happening in BFS? So in BFS you're taking one start node and your adjacency list and your visited array. Okay, you are creating one queue, and then you are marking the visited start equal to true, root node, okay, for the root node, and then you're adding in a queue pair what it would be initially for a start, it will be start in -1, okay, and from next time onward it will be I'll tell you what it will be. Okay, now after adding this, you will run one while loop, okay, until queue is not empty. It will pull the element from the queue which will be current. Okay, current, the if you check the current structure, node and parent. Okay, so you will take you will create two variables, node and parent. You take value from current.node and current.parent. Okay, after that you visit all the neighbor of that particular node, and after visiting that, if that neighbor is not visited, then you will mark that visited neighbor to true, and you will add here is the thing. Okay, you will add the queue, the pair, what it would be, your neighbor and node. Okay, this is what I was talking about. If neighbor is not equal to parent, okay, now you see, now here if you see this else condition, okay, if it is not visited, then you will add that value into the queue. Okay, but if it is visited, who visited it? Okay, if the neighbor is not parent, then the cycle exists, otherwise return false. Okay, if neighbor is not equal to parent, return true, otherwise return false. So that's it. Thank you.